Welcome back, Calc students. We're now going to review 8.2 to 8.3. This will require your calculator, so please take a moment and get your calculator. I'd like for you to take a moment and read problem 1. In the meantime, realize your other co-teachers, Izzy and Ginger, have returned. Izzy, once again, may begin snoring at any time in this video. I will pause for a moment while you read through the problem. Okay, so we have a solid between y equals 0, x equals 3, and y equals x cubed. The cross sections are semicircles that are contained in the planes perpendicular to the x-axis, and we know we have the diameters running between these curves. I'd like you to take a moment and determine how you would integrate. Would it be with respect to x or with respect to y? As you can see, I've created the graph of the region that we are dealing with. I have graphed x cubed in blue, Albert orange is x equals 3, and Tiffany blue is y equals 0. And I have the diameter running between the curves. So the area of our cross section, since these are semicircles, is 1/2 pi r squared. And what we know is our diameter is top minus bottom. So the top, which is y equals x cubed, and the bottom is y equals 0. So we have a diameter that equals x cubed minus 0. Therefore, the radius is 1/2 x cubed. Please take a moment, pause the video, and write your area of your cross section, and then give me an integral that represents the volume of the region. You can see that I've completed the area of the cross section, and I get pi over 8 x to the 6th. Please take a moment and review my math if you do not get that same answer. Then in blue, you can see that I've written the volume equals, I've pulled out the constant of pi over 8, and I'm integrating from 0 to 3 of x to the 6th dx. Now I know this states that calculator is okay, but I want to remind you that this is a problem that you should be able to do without a calculator. And my antiderivative of x to the 6th is x to the 7th over 7, and I can evaluate that from 0 to 3. Please take a moment and get the final answer. I'd like you to go ahead and read this next problem and make a decision on how you would best integrate. Hopefully by now you've determined your best method of integration is with respect to y. And we determine that by deciding what the cross section is perpendicular to. And since it is running from these curves and they are perpendicular to the y-axis, we have no choice but to integrate with respect to y. So I'm going to have you pause the video and get an accurate graph drawn on your paper, and then decide the area of the cross section. You can see that in green I've drawn the leg of the isosceles right triangle, and I've labeled those x values. This x value here is the left, which gives me the large, oh my, I don't know my right from my left. This is the right, and this gives me the largest x value, and this is the left and gives me the smallest x value. So we can now determine that the leg is right minus left. This will give me negative 2y squared plus 2. What I'd like for you to do now is set up your integral. As you can see in pink, for my volume, I have an integral, again, that I've pulled out the constant of 1/2. I have negative 2y squared plus 2. I need to square that, dy. I want you to take a moment and make sure you know how to enter this into your calculator. We do get approximately 2, 3. Okay. In this one, I've already provided you the graph. This is a more complicated graph, a semicircle. with the center at 4, 0. Excuse me. And we're now going to take this semicircle and we're going to revolve it around a horizontal line, y equals 5. So the first two problems came from section 8.2, and now we're moving into 8.3. So if I draw the horizontal line, y equals 5, I have to make the decision how I'm going to integrate. Once again, with respect to x or with respect to y. Hopefully you've realized that since y equals 5 is a horizontal line, just like that x-axis, we will integrate with respect to x. We will also think about taking just a little sliver. This is our little thin sliver, and we're going to think about rotating that. And when we rotate that, we have to make a decision. Will we have a washer or a disc? Go ahead, take a moment, make that decision. Since there is space between the area that I'm revolving and the axis of revolution, I know that I have a washer. So this is a washer problem. And that area of the cross section will be the big circle's radius squared pi minus the little radius squared pi. So our job now is to determine what is big R, what is little r. To determine big R, I'm going to think about the point in my little sliver that is furthest away from the axis of revolution. And I'm going to think about that rotating around that axis. Now I know I do not make the best circles, but that's okay. So from the axis of revolution to that point furthest away, that is big R. And I have to think who's above and who's below. And so above is y equals 5 and below is y equals 0. So big R turns out to be 5 minus 0. Now we need to figure out little r. Little r is the point in the little sliver that is closest to the axis of revolution. That is the pink point. And when I think about revolving that around there, that creates that inner circle or that space. And again, I have to connect it to a point on the axis of revolution. So my little r is going to be 5 minus square root of the quantity 16 minus x minus 4 quantity squared. And that's my little r. What I'm going to encourage you to do is pause the video, get an integral set up, and then take a moment and put it in your calculator to get a final answer. As you can see in blue there, I've written my integral and I've gotten a final answer. If you are struggling with any of these first three problems, again, I encourage you to take advantage of my live sessions and ask questions. Okay, now we're going to work on example 4. So please go ahead, read the problem. After you've read the problem, I'd like you to determine how do you integrate with respect to x or y. After the rotation, does that create a washer or a disc? Then I'd like for you to get an integral setup. Please pause the video if you need to take time to make those decisions. Once again, these are problems that you can use your calculator. So I definitely want to encourage you to utilize that calculator to do the calculus. So get your graph, think about integrating on your calculator. You should not simplify things, and you should definitely do all integrations on it and not antiderivatives by hand. Okay, you can see my graph below, and you can see that if I revolve this around the x-axis, that I will be integrating with respect to x, and I will have a disk. Okay, there is my setup for my cross section in green and then my volume in pink. Again, I needed to find that radius, which was determined by y equaling 2 plus x cubed, and at this point y equaling 0, and I have that above minus below effect. Okay, now to some more challenging problems. Go ahead and read this problem. Now I'd like for you to take a moment and draw a graph. Okay, you see my graph? I'm going to rotate this around the y-axis, which means I'm going to have to integrate with respect to x. I'm sorry, let me take that back. I have to integrate with respect to y. I also realize that there's space between, and I will have a washer. I would like for you to work through this entire problem, so please pause the video, take time to work through it, and come back and check your work with me. As you can see, I have completed the problem, and you can see in red I have big R, and in purple I have little r. I have my cross-section set up, and I have my integral. Again, this is another problem I'm more than happy to work with you through the live session. We're going to get through one more problem, potentially two, but I'd like to for sure get through 5B. So please read through it and set up your graph. So here you see my graph, and you see that I've incorporated x equals 16. And I'm going to rotate around that. Now, the direction which this is rotating is going to change because the axis of revolution is on the right side of the solid versus the left. And we have to keep that in mind when we're thinking about our big R and little r. Before I continue, Izzy has fallen asleep, by the way, and is snoring in the background. I want you to go ahead and set up your big R and little r. There's my big R in purple and my little r in orange. Now, I know that I'm not showing those revolutions, those circles that we are getting, but remember, we always have a point on the axis of revolution and a point on the function. So, as you can see, I have that. And so I'm always thinking who's to the right, who's biggest, who's to the left, they're the smallest. I'm going to pause this tape here in a moment. I encourage you to do the same thing so you have enough time to complete the problem. You are at the point where you should have confidence in setting up your integral, using your calculator to solve this. Okay, as you can see, I have that completed in blue, and that is my final answer. I did have one more example. I'm not going to take the time to do that right now. However, I do want to let you know that I have some Khan Academy videos if you are still struggling with this concept on my website at orloffmath.weebly.com under Chapter 8 Notes. I will also have live sessions, and if you still have a question and am not live, feel free to send me a remind or an email. You will have a test, and your test will be opened up pretty soon, and I will have that information on Canvas. It will be a 16-problem calculator OK multiple choice question through the College Board. I will be giving you until Tuesday at 8 a.m. to complete the test, and it will be timed. If you go over the time when you are asked the time is up and would you like to continue, whatever the percentage of time you've gone over, I will deduct points from your test. I will give you more information on this. If you are able to get through this note sheet and complete your online review without a problem, you are ready to go and you can manage that test. You guys got this. I'm here for you. I hope you're all staying safe, and let me know if there's anything I can do to help you.